Good morning, everyone. We are Quantum Dice, and we want to make your simulations better. Now, today, my colleague and I are going to be doing something a little bit different. We're not only going to be demoing hardware, we're actually going to be, well, not exactly this one that's actually connected to the computer. We're going to be demoing it while showing you exactly how it compares in performance to what you are currently using today, just to show you how inefficient the current processes are. So let's talk about simulations. Within a bank, within a financial institution, there are so many different types of simulations. So let's take the first example, one of the most common applications, which is in pricing options. Now, when you look at this curve, this is an immediately run simulation. In the blue curve, this is what you get from our solution, the quantum accelerator. Now, as you compare it to the current industry standard, you see that no matter how accurate you want your final answer to be, you get a performance advantage by using our hardware solution. In fact, you get up to 50% reduction in computational steps needed to get the answer that you want. Now, what that means for your organization is that you reduce the total computational cost of a simulation, so you spend less on it. You reduce the energy consumed by such a simulation, and within an organization like a bank, that's a lot of CO2 emitted. And also, you get an answer quicker. So in an application like trading options, this could be critical for your organization. But it's not just a one-trick pony. So let's look at another very common simulation that's run within banks, and that's value at risk. So this is a model of how exposed you are to portfolio fluctuations. Now, this one is actually running live. So as you see, the blue curve, again, is our quantum accelerator versus the orange one that gives you the current industry standard. As you can see, we have already converged to a result while the current industry standard is still looking to find what the actual value at risk is, and it only gets it now. So not only do you get a significant improvement, again, in the number of computational steps that are needed to find the result, so again, affecting directly your bottom line by allowing you to reduce the computational step to get it, this time we see something even more interesting, which is that we are achieving a different final result. So we're estimating a higher value at risk. Now, the immediate question is, why is your one the one that's actually true? Maybe you don't want to see that kind of exposure. Maybe you're getting something that's overestimating your risk to the market. Well, we didn't just do the actual model. We looked at what's under the hood. So let's take a sneak peek into what's under the hood. Working with one of the biggest research centers in computational mathematics in the UK, we've investigated how these systems sample the probability space. Now, when you're looking at doing a model like value at risk, you're looking at different potential scenarios, and you're trying to estimate the risk of those scenarios on your portfolio. Now, you might think that between these two examples, so the one on the left is the current classical solution within the R statistical language, and the one on the right is our quantum-based solution. You might think that they seem to be sampling the space quite the same way, without any biases. But however, take a switch of orientation, and what we can see is with the classical solution, there is an obvious pattern. There's an obvious bias to what is actually supposed to be a very statistically random approach. Now, what does that bias mean? What does it do? Effectively, what it means is that you're not getting a representative view of what are the actual potential scenarios that could happen. And that not only means you have a less efficient simulation, so you need to take a bigger sample, you need to spend more on computational resources to get that solution, but you also get an inaccurate one. Think of an opinion poll. If you try to take an opinion poll without taking a representative sample, your answer is just not going to be that accurate. So if we go back to our value at risk model, basically, this difference between the two estimates is meaning that what we are doing is more accurate. We're giving you a better estimate of what your actual value at risk is. And if we can learn something from various different events over the past 2 decades, getting the value at risk right is quite important. Now, let's take a look at what this overall means for your organization. Now, if you are interested in getting a better result, in getting a more accurate insight into what you need to do, and in getting it with fewer computational resources, and spending less on these kind of computational tasks, and in leaving a less of an environmental impact due to an enormous amount of computation, well, this is the solution for you. There are multiple ways you can deploy it within your organization. So one way to do it is to just take one of these devices, slot it within your computer, and it's going to enable all of your simulations to run with all of the different advantages that we are providing today. If you prefer something a little bit more deployed across the entire organization, we have a solution that's in the form of a server that can be deployed on premises, connected to your computing systems, allowing you to gain all of these advantages. And of course, there are certain organizations that don't prefer to deploy hardware, so we have developed specifically a hardware as a service model, where you can connect to an online API and still get all of those same advantages, and of course, reducing your overall spend on cloud compute. Now, if this is something that you think your organization could be interested in, come to our booth and speak to us. We're going to be here today and tomorrow. You can't have this one because this is already going to a different client tomorrow, but we can speak about getting you with our devices as soon as possible and giving you all of the advantages so you can give your teams the infrastructure that they need to make their processes more efficient. And thank you so much for your attention, and see you later.